So today we are going to start with complex numbers. This video is just offering a basic intro on the topic complex numbers. Now, what is complex number? Complex numbers are those numbers that are the combination of a real part and imaginary part represented as a plus iota b, where a is the real number and iota b is basically the imaginary part. Now, what are these things? What are real numbers? What are imaginary numbers? Real numbers, as we are all familiar, that they are those numbers that can be positive, that can be negative, that can be any values. It can be decimal, can be fraction, can be any number. For example, we have 15, 0, minus 21, any number basically in they are just coming under the category of real numbers. Now, what are imaginary numbers? Imaginary numbers are those which are not real numbers. They are basically negative values under the square root. For example, we have under root minus 3, under root minus 10, and under root minus 12. To solve these imaginary part, to solve these kind of equations which don't have any solutions, which don't have real roots, we are being introduced with complex numbers. So complex numbers are introduced for these things, and we have equation over here in front of us. We have x squared plus 1 equals to 0, where x squared equals to minus 1, and basically x equals to under root minus 1. To solve this under root minus 1, we are being introduced with complex numbers. So we have this under root minus 1 being denoted as iota. So I is the symbol which is being used, and it is being equal to iota, that is an imaginary number, to represent under root minus 1. So over here we have just notations that equals to a plus iota b, basic you can say combination of real and imaginary part. So we have over here real part, real under the bracket of z equals to a, and imaginary bracket z equals to iota b. So we are just facing some kind of basic examples over here. We can see that under root 4, under root negative 4 we have over here, and we have just to break these part into under root 4 and into under root minus 1. And as we all know that under root minus 1 is basically being denoted as iota, and under root 4 can easily be solved because we know that 2 would be the answer, so that is basically 2 iota. Now same goes with under root minus 5 and under root minus 16. We are again facing some kind of basic examples where we can just differentiate between real numbers and imaginary. For example, we have a minus 2 plus 7 iota, and we are having minus 2, and then we are having imaginary number as 7 iota. Other examples can easily be seen, and their real numbers and imaginary numbers can easily be found. Now, how to find the modulus of a complex numbers? Modulus of a complex number can easily be found through the formula under root x squared plus y squared. And here are some basic practice questions to solve and to find modulus, which can be very easy. Now, the graphical representation of complex numbers. So we have over here 2 plus 4 iota, and as we all know that 2 is basically our real part and 4 iota is our imaginary part. So real part is basically the x-axis and imaginary part is basically the y-axis. So 2 is basically being marked over here, from over here, and 4 is basically being marked from over here, representing the equation 2 plus 4 iota, representing this complex number, and we can draw the sign easily over here to represent this 2 plus 4 iota, where we have imaginary part as our y-axis, and real numbers can be written in our x-axis. So here are some basic examples and basic questions to be solved, and to just draw into the graph to get yourself familiar with imaginary axis with real axis and how to represent complex numbers in graphs. Thanks for watching.